Alright guys, so today's the day. We're back at the tree. Finally got enough time to get a day to come back here and got some help. Got the machine running and set up. Added some lift points and some stuff in the front to pull on. You'll see it here in a minute. Here's the big tree. Got it all cut up, got the best direction picked to mill. And we're about to get started here. Huge son of a gun. That is my foot. That is a massive tree. All right, I'm excited. Let's get going. All right, here goes nothing.
What's the matter with it?
Leaking, fuel leaking out of it too.
Did that come out of that hose? I think that's that hose, isn't it?
I don't know. It's not idling high enough though, and something. Hear it running like shit. Fuel hose. Leaking out of something else.
It's not the hose?
Dripping on the hose. Push that linkage. I can C-clamp a bar to the side of that.
That's what I just put two tabs and C-clamp them on. Just take two pieces of flat and just C-clamp them on so they slide down it. Yeah. And then you don't have
roller would be even better, but yeah, this sucks. And plus it's also dangerous. You get to stand right here. If you had those on there and didn't have to stand here, you wouldn't even have to steady it. Let's go grab that cowling. I'll grab some. It's laying in my garage. It's working though. We're cutting. It cuts. It's not even really bogging the motor. I mean, the motor's just not running right. But like when you drive it, it's not really bogging the motor. It's cutting fine. Alright guys, so the tractor made it out of the woods. You can see our big slabs here. That's my feet. These are some pretty big logs. There's still a couple more to get out here, but these are monsters. I mean, we milled them 4 inches thick. They're 57 inches at the widest spot, and then they neck down to like 50 inches ish on the other side, 48, somewhere in there on the biggest ones. So we got these 5 out of it. There's still some more to go. It kills about 1 chain. Yeah, it kills about 1 chain per slab. And you can see we got a little bit of rot here in the first few slabs. That it was where the 2 trees, there's actually 2 trees this size that grew together, and literally at the base of the 2, it's almost 10 feet across. It was an absolutely massive tree, but the other side fell down several years before this one, so the wood is I haven't dipped into it with the saw yet. I might try to, but it's going to be pretty rotted. And this one had some good rot in the base, and you can see it kind of persisted. The last slab, I think, is this one below this one. That's the best one right now, and it's pretty much all the rot's gone in that one. But we'll probably be able to get 3 or 4 more out of it that are pretty big. So, yeah, I'm pretty excited. Can't wait to get these dried out. Got to get them stacked up, paint the end grain, put some stickers between them, bind them down, put some weight on them, let them dry, and then go from there with these. And hopefully we'll be making these into some cool tables and whatnot. So. Alright guys, so I got the machine back at my shop. I was just going to do a quick little run through this just for those of you that haven't maybe been following along for the whole series. So what we got here, there's a 60-inch bar on the saw. Okay, this is a 25 horse V-twin off a lawnmower. Vertical shaft motor right there. So I got it all wired up over here to this control panel. Here's the panel. This is the choke, and then this little PTO engages the electric clutch on the bottom. It's right here. And this would normally feed your mower deck, but in our situation it feeds these belts over here. So the power runs from that motor through these belts. They're on a tensor. This is a backside idler. I put the front side idler in just to keep this from slapping, and it seemed to help. And then it runs over here to this pulley, which is mounted on flange bearings with a 1-inch key shaft, which then runs down here to our chainsaw sprocket. So this is just a shaft collar right here. This is a chainsaw sprocket that's bored out. I turned it on the lathe and made a keyway that fits on the 1-inch shaft. And then you've got a little tensor mechanism. You loosen these 2 bolts and the 2 bolts at the other end of the bar, or nuts, I mean. And then you tighten these 2 bolts, and it pushes the chainsaw bar away from this sprocket, which tenses the chain. So you can get the chain nice and tight. And then I've got a little lube container here with bar oil, not cutting oil, and a little valve to meter it, and then a clear pipe. And then it just is housed down there, and it drips oil right on the bar where it meets the chain and the bar together. This is just a fuel tank. And then I got the battery off right now because I got on trickle charge. This thing's probably gonna be sitting for a little while since I'm done milling. Battery would normally set there. And then I've got some little removable feet that just pop off. They just unscrew once you start milling. This piece of plate was clamped on here just because it catches the edge of the frame rail when you're milling, and it keeps the saw from pulling that way. And then you don't even have to hold on to it, you can just crank it. This is the tensor for the spring that's on the back of this pulley that then tenses the chain, so you just tighten this up. This was just, I added this on after the fact. You can tell I ruined my paint. This was just to hook on to the crank to pull the thing through the log. So that's all that is. And then for the depth of cut, I've got these polished shafts running in these bushings I machined with bronze inserts in them. The shaft collar is just loosened, and then you can change the depth of cut and then you tighten those shaft collars back down. So that is a quick little synopsis of the machine. Now, having actually used it now for a good while and milled several slabs, really big slabs too. I mean, we were milling 57 inches. That's the max capacity guard to guard on this thing. And we were at max capacity in a few spots. So a few things I learned. One is the chain is super important. Well, actually not super important, but it is super important that it's sharp. So originally I had this chain here. Or actually, sorry, wait. Yeah, no, that was this chain. So this one here, this is a specialty ripping chain, more expensive. It's got these little half teeth. So there's 2 half teeth that are like scoring cutters, and then you have 2 full teeth, and then you have 2 half teeth, and then 2 full teeth. And it's supposed to run smoother and leave a better finish and whatever, versus a normal chain. And these are ground at 10 degrees. It's a 10-degree grind, so it's not super sharp. This is a regular crosscut chain, 30-degree grind on the teeth here, and it's a full chisel chain. So this, I bought a whole roll of this and just made some of these because I had this one to start out with, and then I started running these full chisel ones just because that was all I could get a hold of here in town. And honestly, there wasn't that much difference in cut quality from the more expensive ripping chain compared to this 30-degree regular chain. But this chain did induce a lot more vibration than regular 30-degree full chisel chain. So what I did is I made a skip tooth chain, which if you see over here, this is a full-size cutter. These 2 I cut off with a cutoff wheel, and then 2 more full-size ones. Same thing down here, 2 full-size, 2 chopped, 2 full-size, 2 chopped. So every other left and right cutter is gone now. I ground them off with a cutoff wheel. And that actually produced the best results for reducing vibration, because in those big slabs, we were milling 12-foot long slabs that were 5 foot wide, almost 5 foot, like 57 inches in the widest spots. And you could really only get 1 slab on a chain. And then if you tried to mill a second slab, partway through the second slab, the chain would be just torched and completely dull. And then you'd really have to fight this thing to get it through. And it started inducing a lot of vibration in this whole setup. So the skip chain, you have less teeth in the cut. You got like essentially half the teeth cutting at once. So it's a lot less load on the whole machine. And it wasn't a deficit of motor power for sure, because 25 horse is plenty powerful. But when the teeth get dull, you start to really load the chain, and then it would cause vibration back here on the jack shaft, and it was like vibrating the shit out of everything. So I think, or actually I know, that the skip chain produced less vibration, but it cut slower in comparison than the full chain, regular 30-degree chain. But comparing the cut quality, there was really no difference in cut quality. And the speed, when they were all sharp, was not really any different. So honestly, I don't know if it's really worth buying the more expensive chains. And, you know, this is me and my experience, you know, with this saw. You know, maybe this doesn't apply for everybody. But for this machine, I experienced really no difference in quality when they're sharp. The biggest thing was just having a sharp chain, because once the chain is dull, it makes it so much harder to cut, and it makes the cut quality go down because you get that vibration. So the skip tooth helped, but they all wear out. Honestly, you get about 1 good cut, 12 feet, and then the chain's toast. So I think in the future, what my plan is, I've been looking into Carbide chainsaw chains. I don't have that. I've never used one of those before, but I've heard things about it from guys in the industry that use them for cutting nasty wood, like at a chipping plant, or a mulch plant, I mean. And apparently they'll cut like all day long. They're not as sharp off the get-go, but they don't get dull. They just kind of keep on cutting at a mid-level amount of speed. So I don't know. I might try one of those Carbide chains. But in the future, when I do this again, I'm just going to make several sets of chains. I'm going to get a whole loop of chain and just make a bunch of chains. Have like 5 or 6 chains, all sharpened and ready to go. And then I'm just going to rotate one. If it depends on the length of cut, but like these slabs were huge. 57 inches.
57 inches wide and 12 feet long. That's a big slab. So if I do anything this size again, I'm just gonna change the chain after every cut and not mess around with fighting the chain if the Carbide doesn't have any better performance. So yeah, that's my 2 cents. Don't waste your money on the ripping chain. Doesn't appear to really do that much different. And just get yourself several chains and sharpen them after every cut. That would be my advice. But there might be guys out there with more experience or a different setup, but for me, that's how it worked. But with regard to the machine itself, performed great. They cut the slabs. It's got plenty of power, but as I figured, the chain speed I think was a little bit of a problem. So I can only run 4,000 RPM through these flange bearings. So I'm limited with how much I can change this pulley ratio, because I could give myself 20,000 RPM if I change these pulleys to the right sizes. And lots of people recommended that, but I understand that that's how you do it. But I can't put more than 4,000 RPM through this flange bearing. And I've already got an oversized chainsaw sprocket, which will increase the chain speed, because more teeth getting pushed through the cut obviously increases your chain speed. But I can't go any bigger than that, or else the chain is not going to touch the bar, because the chainsaw sprocket will be so big that it won't even get on the bar. So I'm limited by these bearings. I can buy more expensive bearings. They're substantially more expensive than these $20 bearings. It's like a $200 bearing or something. I forget how much it was, but they were super expensive to get ones that can handle higher RPM with that big of a shaft. But in the future, I may upgrade those bearings and change my pulley ratio, because I think if the chain speed is faster, there will be less vibration, because the saw will be less apt to bite in and cause vibration if it's tearing in there so fast that it's taking smaller bites instead of really deep bites. So I think that may help. And if I had to do it over again, I would probably have used bigger shafts for the bar mounts, just because this whole thing, when it gets under load with the chain, when the chain's sharp, it runs flawlessly. But when the chain's dull, it starts vibrating all this stuff. And the shaft, I could see the shaft vibrating, and the whole bar could actually move, like really slightly, but it could move side to side. So I think I would change those to a bigger shaft, and then I would machine a crank mechanism so I could actually just crank these with like a piece of Acme thread or something attached to the top. That way I could crank these up and down, because setting the depth of cut's kind of a pain in the ass with those shaft collars. So that's another thing I would change. And also, I started dumping water on the bar. I had the oil running all the time, because it's got to lubricate the chain against the bar, or else it'll wear both of them out. But I started dumping water on the bar just to keep it cool, because the thing gets pretty dang hot when you're running full bore through those big slabs. So in the future, I think I'm going to add a water tank as well to cool the bar down. That way it'll increase chain life, cool the machine down, and it'll overall just probably cut better. So yeah, that's the big upgrades. I would change those bearings out, get the chain speed a little higher, potentially make cranks to set the depth of cut a little bit easier. I would add for sure a water container to dump water on, just for bar cooling purposes. And then change the chains out more often. You know, don't worry about like trying to push it, because it ends up just taking so long to cut that it's not worth it. You might as well just change the chain, because it takes like 1 minute to change the chain. So, oh, and the other thing too is my tensor mechanism is modeled off a regular chainsaw, and it's pushing the bar, which causes a little bit of a belly in the bar. And you can get it out, but you have to lift up on the bar before you tighten the nuts at both ends. So like before I tighten these down, I have to lift up on the bar and then tighten them down. And then it still bellies about probably less than 1/8 of an inch, but it still bellies a little bit. I think if you had a tensor that pulled the bar versus pushing it, if you had it on this end and it pulled the bar, it would actually help reduce that belly, and it would pull the bar tight. So if I had to do it over again, I would put the tensor on this side as well. But overall, I am more than pleased with this machine. This is not my occupation. This is just some stuff I play around with in my free time here on the farm. And this little project, it didn't cost that much money, and it was fun to machine these parts. And this was a motor I had laying around anyways, and it works great. You're not really wearing out a big expensive saw. It's not that hard to build this setup, and with a couple little modifications, I think you could work out all the kinks and this would be like, I mean, stellar. I mean, it was stellar. With a sharp chain, this thing was hogging through those logs and there was absolutely no problem. If I would have changed the chain every cut, I don't think we would have had any problems whatsoever. But I just wanted to put this out here with my thoughts on the machine in case anyone decides to try and build something like this. Might help eliminate some problems for you that I had. So yeah, that's my thoughts. But overall, I'm super tickled with it. And the thing runs quiet. It's got a nice big motor on it. You could run this thing all day. I mean, we did run it all day. So yeah, it worked great. It's a heck of a chainsaw mill. And I'm excited to see if I can get a hold of some big logs again. And maybe make a few modifications to this bad boy and then take it out again for some more cutting. So hope you guys like that. I got some more projects coming up here in the future. Oh, this was the hand crank too. This mounted to the end of this frame here on that flat bar down there. I would just clamp this with C-clamps, and then I would use this little boat winch to pull it through, and it made it effortless. It took literally 0 effort to pull that thing through when it's that attached. But anyways, some more projects though. I'm working on this hydraulic lift table I've had. I got a little excited putting a valve on it, and I split one of the hydraulic couplers in there. I cracked it because I tightened it too tight. So I got to get to pulling that off. I'm going to put up a video about this guy. I redid some stuff on my hydraulic unit. Works great now. Also, I've got some videos coming up on the big lathe over here. I put a lot of work into getting this guy running. Got the VFD all set up and everything. I think I got a little bit of some footage I might be able to post about it. I haven't machined a lot with this, but I've had a few little odds and ends things, did some threading. I actually made a hydraulic part for that hydraulic unit. And then also I might have some footage on the mill too. It's been a busy summer. I've had a lot going on, so I haven't had a ton of time to film. I have like lots of little snippets of footage from random projects. Oh, I got some from this over here too. I braze welded this leveler back together over here. So yeah, anyways, thanks for following along, guys. Hope you enjoyed this project. I'm looking forward to some stuff in the future, and I hope that, you know, somebody finds this cool or useful or whatever. So, all right, guys. Thanks.